What's up, Algebra 1? This is lesson 14. Our objective is how do you find theoretical probability? Well, before we define whatever this is, theoretical probability, we need to define a couple other terms first. The first one is sample space. A sample space is a set of all possible outcomes of an event. So if you were to roll a number cube, it'd be 1 through 6. Those are all the possible answers you could get. If you was talking about a deck of cards, you'd be talking about each individual card in the deck. There'd be 52 different things in that sample space. A simple event is an event only having one outcome. So you're only going to roll the dice once. You're only going to pull one card out of the deck, or you're only going to pull one marble out of a bag, let's say. So there's just one simple outcome. We'll learn about more complicated ones later, but let's first take care of the simple ones. All right, so that brings us to the theoretical probability. Theoretical probability is simply a ratio of the favorable outcomes, meaning the ones that you want, divided by all the possible outcomes, or the sample space. So let's just try one of these real quick and see if we can understand what that would kind of look like. There are 4 green marbles, 3 blue marbles, and 3 red marbles in a bag. So let's just talk real quick. The sample space would be green, 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 because there's 4 green marbles, blue, 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 because there's 3 blue marbles, and red, 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 because there's 3 red marbles. And notice this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 in total. So let's go ahead and keep going, I guess. What is the probability of randomly choosing a red or a green marble? So let's think about how many red marbles are there? Where there's 3 red marbles and there is 4 green marbles. So remember, the word or means either one of those would be okay, right? If you were sent to the store to buy Coke or Dr. Pepper, as long as you came back with Coke or Dr. Pepper, then you'd be okay. You'd will have fulfilled what they asked. So if I picked any red one out of there or any green one out of the bag, then I'd be happy. So what we're going to do is we're going to add all the favorable outcomes on the numerator, on the top. So there are 3 red plus 4 green. And on the denominator would be all the possible outcomes, which is simply 10. So we're talking about 7 over 10. That's the probability of picking either a red or green. And if we remember back to what different class was talking about, I think we'd call this likely to happen, right? That's talking about 70%. So that'd be likely to happen. Part B says, what is the probability of not choosing blue? Not choosing blue. Well, pretty much it's just 3 marbles, green, blue, or red. So if I didn't want to choose blue, that means I could either choose a green or a red marble. A green or a red. Well, we just talked about what it would be to pick green or red. So that means this is going to be 7 over 10. Because there's 7 possibilities of not choosing blue. Alright, now if you think about this for a second, it will make sense. The probability of something happening, like saying the probability of rolling a number 1 on a dice, plus the probability of not rolling a 1, meaning rolling a 2, 3, 4, 5, or 6, if you add those 2 probabilities together, you'd get 1. Let's just look at that one real quick. The probability of rolling a 1 would be 1 out of 6 options. And then the probability of not rolling 1 would be 5 out of 6. And if you add those together, it would be 6 out of 6, which is just equal to 1. Okay? And then another way of looking at that would be the probability of not an event happening would be 1 minus the probability of the event actually occurring. And that's just because we subtracted this to both sides. Alright, so let's look at these couple examples here. It says, what is the probability of picking a face card from a normal deck of cards? Now, let's go ahead and just refresh our memory for a second. There are 4 suits. Each suit has 13 cards in it, an ace through a king, and the face cards are the jack, the queen, and the king. So there would be 3 face cards for each suit. So that means there would be 3, 6, 9, 12 face cards. So what's the probability of picking a face card from a normal deck? Well, that would be 12 out of the 52 cards in a deck, which will reduce to 6 over 26, or 3 over 13 would be the probability of picking a face card. So what's the probability of not picking a face card? Well, we could go through and start counting all the cards that were not face cards. So we'd say like, oh, there's 4 aces, so add those 4, and there's 4 2s plus those 4, and there's 4 3s, and there's 4 4s, and there's 4 5s, and we can go through and add up all those. However, since we just went through these couple things we talked about, we know the probability of picking a face card is 3 out of 13. So we can use this fact up here that the probability of not picking a face card is going to be 1 minus the probability of picking a face card. So what we're looking for is 1 minus 3 over 13. Or we could write this like this, 13 over 13, because this is just 1, minus 3 over 13 would give us the probability of not picking a face card. So this is going to give me 10 over 13. Alright, I hope that makes sense. If not, ask questions. Your homework is on page 77. Do all 14s, all 13s, plus 10 more of your choice. I know you're going to do awesome. I'm not worried about you at all.